Right, one of these centre of mass and equilibrium problems where you've got a composite shape. This is Edx M3 Jun 2011 question 3, and there's the question. Basically two parts to the question. First part wants you to find the centre of mass of the whole thing. The second part wants you to, tells you something about the equilibrium and wants you to find the angle. So first of all, let's find the centre of mass of the whole solid. So let's go to a new page, and I've set up the usual table of values ready so that I'm not taking too much of your time figuring that out. You might like to pause the video and check these terms. The thing you've got to be careful of here is that the hemisphere is twice the density of the cylinder. So in my masses here, I've called the density of the cylinder rho, and then basically the mass of the cylinder is pi r squared h, which comes to 45 pi l cubed times rho. The hemisphere then, the density will be 2 rho, so that makes it 36 pi l cubed. Check that. And then the total, adding them together, is 81. So the mass ratios are 81 to 36 to 45, which we could simplify for the purposes of the moments equation. We could simplify the mass ratios to what would be 81, 36, 45. We'd simplify down. I don't know if it's worth doing this. We could just use those figures. 945. Now let's change to a sensible colour. Taking moments about O, then we've got taking the mass to be 9 instead of the 81 pi l cubed. 9 y bar is equal to 4 times the distance, the minus 3/8 of 3l. This is the distance of the centre of mass of a solid hemisphere from your formula book. 3/8 of the radius. It's negative because it's above O, whereas the centre of mass of the cylinder will be below O. So carrying on, 4 times minus 9l over 8. Check these figures. Plus 5 times 5l over 2. Sorry, my pen is playing up again. 5 times 5l over 2. Where's the 5 gone? Right. That's an L as well. Right. Tidy that up a little bit and we get y bar equals 8l over 9. Just about done it, even though things are going a bit wrong with my graphics. Y bar is 8l over 9. Okay. While we're on the page, let's just put the mark allocation for that first part of the question for those 5 marks. There was marks for seeing the right values of the mass and the distance in the table. And then there's a method mark and 2 accuracy marks for doing the equation of moments and working it out correctly. 2, 3, 4, 5. That's the 5 marks for that part. The next part of the question, I have taken the liberty of already putting the necessary lines on the diagram. What we have here is a solid. Apologies if it's just cut off the left hand side here. The solid is now placed on a plane inclined at theta to the horizontal. The plane is sufficiently rough to prevent the solid slipping, and it's on the point of tipping. So if the object is on the point of tipping, the weight acting from the centre of mass here, the weight will act straight through that left hand corner, left hand edge. The idea is that on the point of tipping, the reaction force between the plane and the solid now acts purely at this corner. So the weight and the reaction force are in line going through that corner. Right, now we know the y bar, we know the distance of the centre of mass from the centre of the hemisphere. Here's the centre of mass there. So we need to work out 5L minus Y bar, right? 5L minus Y bar is 5L minus 8L over 9. And then we can put that in on the triangle. We can create a triangle with that. That's 37L over 9. Now in the triangle then, 37L over 9, just going to write that in there. Tan of theta is 3L over 37 over 9L. Right, so it's 27 over 37. And that gives us theta equals 36 degrees or 36.1 degrees. So go back over that carefully, make sure you see, well, first of all, make sure you agree that this is theta and that is theta there. And then we just need to work out tan of theta from that. Okay, the mark allocation here, a mark for evaluating that distance, and an M1, 4 marks for this, a method mark for working out tan theta from that diagram with a weight going through the corner, and 2 accuracy marks. Like that, M1, A1 and A1. Okay, that was question number 3 done.